Greetings and welcome to Flanigan's Ecologic. I am your host, Ted Flanigan, and this week we're joined by Nicolò Brambilla. He's the Chief Technology Officer for Nanoramic Laboratories. We're going to be talking about electric vehicle battery technologies and making EVs all the more efficient. Hey, Nicolò, welcome to Flanigan's Ecologic podcast. It's great to meet you and have you on the show.
Thank you, and thank you very much for having me.
Yeah, I'm just delighted. As I said to you earlier, I'm looking forward to learning from you today. And I have a lot of listeners that drive EVs, that are passionate about EVs, and how do we make sure that they're super efficient? But let's go back just for the sake of our listeners. Born and raised in Italy, right?
That's right. Yes, I'm from Italy. I grew up in the northern part of part of Italy, very close to Milan. I'm not sure if you're familiar with the city, but yeah, it's quite a nice area. I actually lived in a small town in between Milan and the Lake Como, which I think many listeners probably know. It was nice. It was fun to grow up there, very close to the Alps. When I was a kid, I really enjoyed to go, hiking or also skiing. Yeah, I've been skiing since when I'm, 4 years old. And to date, I still ski, but I like to go back and skiing there in the Alps, or sometimes I go to Colorado or things like that, which is also quite nice.
How fantastic. We just got back. We had a big family trip to Colorado, just got back last week. And so skiing is a mutual passion, but what a gorgeous part of the world that you're from. I've been through that part of Italy. I love Italy. And I take it you still have family there and you're able to go back and visit?
Yeah, no, you're right. Actually, all my family is still there. And yes, I go there maybe once or twice a year. During the holidays is really nice. So yes, I enjoy to go there. And since we're also very close to Switzerland, France, so sometimes it's very easy to actually drive also there. Everything is very close. Yeah.
So what did you study in college? What was you mentioned skiing and sort of outdoor activities, but then what did you focus on?
Yeah. So what I focused was at the beginning was physics and engineering, which mostly focusing on kind of the science of materials, optics and things like that. So that's how I started. I studied at the Polytechnic University of Milan. That's where I started. And afterwards, I actually moved to France to pursue another kind of degree. That's where I specialized in nanotechnologies. And in particular, I was working in a lab where we were studying nanocarbon technologies, which at that time, I'm talking about 2007, 2008. It was still kind of the early stage of those kind of materials. They were very exotic, and so I studied there how to synthesize these kind of materials, what kind of properties they had, and really that is what got me into energy storage afterwards. Yeah.
But let me hold on a second here. What is a
Sure.
nanotechnology? Is that just I think of nano being extremely small or extremely short, or is that what?
Yes. Nano, like technically speaking, nano is 10 to the minus 9 meters in this case, right? So nanometer. So it's something very small, and there is a science that really studies all the properties of different materials when they are so small. Because when things get very small, actually they behave a little different, and it's really possible, for example, to engineer new kind of materials that have amazing properties just by engineering at the nanoscale level, sometimes at the atomic level. And so there are a lot of techniques on how to change the properties of those materials, how to make new materials, how to improve kind of the performance of some of these materials, whether it's a mechanical performance, thermal performance, electrical performance, so you name them. There are, you can really do a lot of cool things. And
But Nicolò, you make it really small so that you can synthesize it or you can manipulate it in some way, and then obviously you have to scale it up, right?
Absolutely. And that's actually a great point, because those things are very, let's say they're, very easy, actually not very easy, but like you can really study them. You can replicate things at a small scale in the lab, but really the challenge is how can you take what you have in the lab and being able to really bring them to industry, to scale them up, to produce tons of these materials, or to use new processes to modify materials at large scale. That's really a big challenge. It's not something that you learn at school by any means. It's something that really, so you need to look at processes and new, a new type of materials that can be scaled. They are cost effective as well, right? So those are things that you look at when you start working for companies. And I think there are many great, new companies that are looking into those things.
Yeah, it sounds like it. So I did cut you off. I apologize. You made me excited, but you were talking about going and doing some additional college or studying in France, and
Yes.
you were studying these nanotechnologies, and that's when you really got into the energy storage aspect of nanotech and that application, I guess, of nanotechnologies. Is that right?
Yes. Yeah, that's right. And um, one of the things that you need, for example, when you make a new type of energy storage or to improve, like energy storage, like for example, lithium-ion batteries, which is something that I work on, actually today. There are other types of energy storage where you need, for example, new properties like very high surface area. You need a high surface area. So you need to be able to modify some of these highly kind of electrically conductive materials and increase the surface area. And so that's really what I did at that time. And I was looking at new carbon nanomaterials with very high surface area that are able to store like 5 to 10x more energy in the same surface area. And that was kind of the starting point, really, what really got me into nanotechnologies, but really like specialize in the forms of carbons. Like there are different type of carbons, like carbon nanotubes or graphene, which, actually today are commonly used, I would say, in many industries. But at that time, it was something very new. Yeah, so I was one of the first, people to really look at the properties of those materials and more specifically how they can help in the energy storage industry.
Now, does this high surface area? It sounds like that's on the electrode, right? You're still working with like a lithium ion in that case, or could be any chemistry? You're really focused on the conductivity aspect of it.
Yeah, so actually, you really got the right thing, which is the electrode. So the electrode is really a key component in all energy storage, not just in lithium-ion batteries. For surface area, I would say that in different types of energy storage, like for example in the electric double layer capacitors or other types where really surface area is needed, then yes, then you use these carbon materials to increase surface area. But you're right that the electrode in general is really a key component in lithium-ion batteries as well. Like for example, anode or cathodes. Those I would say really are the key component that you have in a battery, and that's exactly what we do in Nanoramic, which is the company that I work for right now.
Yeah. Okay. Yeah. Fantastic. We're really getting ahead of ourselves, aren't we? So you're in France. You do this as I guess graduate level study, and then what brought you to America? Was it a job? Was it a woman? What brought?
Yeah, it was not a woman actually. After, let's say, after I finished my studies, actually, I started to work for a French company called Thales, which is a very large company that makes all kind of aerospace and defense kind of systems. I was working, for sensors, MEMS, the gyroscopes and things like that. And at a conference, I actually met, this one professor who was the advisor of one of the two founders who actually founded the company that I'm now working for. That's how I got in touch. I met this person, and he was telling me, I know this new company that is in Boston, and they actually started to work on energy storage based on nanocarbon technology, and that's really, it's something that really sparked immediately. I will, caught a lot of my attention because that was really what I was really passionate for. And yeah, and that's how I ended up basically moving to Boston. At that time, we were like 3, 4 people. Actually, I believe I was the first employee of the company. That's that, I'm talking about 2010. So that was back in 2010. That is when I moved here to Boston. I quit my job in France and I decided to just move here. Yeah.
Well,
So
before we get back to sort of the technical, what was it like then moving to America? You're
yeah.
into America, your family's back in Italy. They must have been saying, "No, please don't go." Uh, you're stuck
Yeah, I
off
mean,
on your own, huh?
yeah, I would say in the first few months was, of course, was not easy because all my friends and families were all in Europe. Either they were in France or in Italy. So really, I didn't know anybody here. But I found that, yeah, people here were, really nice. It was easy actually to, yeah, to get to know people. But also, I would say the company at the time was very young. I was focusing a lot to try to make things better there and to grow the company. And I was, extremely excited, and still to date, I'm very excited. So it was not, it was just hardly the first couple of months, but after that, I think was a really nice thing, and I really love this country. So that's why
Yeah.
I actually decided to stay.
That's really great. I think you must have been very brave to do so. But anyway, that's great. And you had this company that was really aligned with your graduate studies and just where you want to take the nanotechnology was right into the storage space. So how does a company like that survive? Are you selling? You do a lot of research, right? And then do you sell results or patents to other organizations, or what? How does what you do, like we were
Yeah,
talking about, get scaled and get into commercialization?
sure, sure, sure. Um, yes, and so this is, by the way, what we focus on. I think what we are really good at is to take new technologies, to scale them up, to prove them that it's possible to scale them. So we de-risk all that aspect. Um, and then, as you mentioned, what we do is we partner with other companies that have all the manufacturing capabilities. And what we do is we partner with them either through a license. So basically, we license technology. We teach them how to use them. And then, of course, we make our revenue through the royalties, and through basically all these fees that come with the license of this technology. So really, our focus is, let's look at new kind of technologies that are very challenging. They have a lot of potential, but really it does require a lot of work to actually make them work in the real world, because it's something might be very cool, but it's not cost effective, for example, so it's never going to fly, right? So really, you need to look at all the aspects, not just the technology part, the cost, the supply chain. There are a lot of things that really we do, and I think we are really good at. Um, in the early days, as a company, really, we were able to raise quite a bit of money through also, through grants. We worked along with the DOE, ARPA-E, for example. I myself, when I started here at Nanoramic, actually, I was the project lead for a very large project we had with ARPA-E. That is actually how the company got started. The company got I believe it was $5.5 million at that time, from the government, to work on this new kind of energy storage using carbon nanotubes. And afterwards, we also got many projects also with the DoD, with NASA, to make like specialized energy storage that were able to work in a very wide temperature range, either for very high temperature environments or very cold temperature environments. So this is really in the early days how we basically run the company, and so we did get funds and also some private investment as well, of course, until we got like a very stable product, high temperature supercapacitor. It's kind of it's similar. It looks like a battery, but it does not have lithium, and it can be charged and discharged for almost infinite times. Just the energy density is not even close to the one of a lithium-ion battery; is much lower, but it is used, for example, for bursts of power. Yeah, so it has some specific kind of applications. And yes, we were able to sell this to several customers, and we licensed this product out as well. And so basically today we have royalties that we can collect out of this product. We also, this is how, that's our most kind of mature energy storage product. We don't only make energy storage. Actually, we developed also what we call the thermal interface material, which is a polymer composite with very high thermal conductivity. Basically, it approaches the thermal conductivity of some metals, but it has the mechanical properties of a polymer. So it's very soft, it's very squishy, and it is used to interface different surfaces so that you don't dissipate heat, right? So you want to be very, you want to transfer heat from a heat source to a heat sink, for example, without losing too much heat. And that was a good story because we developed this new product. We had several customers, and we actually ended up selling off this kind of division to Henkel, which is a major chemical company, and this is public information, so you can also find it online. But that was a good story because really it showed how it is important to really work on new technologies, de-risk all the aspects, and then partner with a company that can actually make this in large volume. Because we don't specialize in actually building those large factories, but we specialize in developing new technology and try to de-risk all the scale-up, kind of risks that you have, including, kind of the process itself, the cost of things, where you buy things, so all the supply chain, and then we work with other companies to be able to commercialize it.
Sounds very rewarding, but it's got to be a tough path, right?
Absolutely.
You try and try.
It's not. Yes. It's actually, of course, it is actually challenging. It seems easy, but it's actually challenges. And I would say there are two types of challenges. I mean, first of all, there is a technical type of challenges. You're trying to do something that nobody else did before. So you fail many times. And it's normal to fail. If you don't fail, that means you're not doing things well enough, right? So I think at the beginning, there is a lot of failure, but eventually you learn. And you need to be agile enough to be able to learn from the mistakes. And you get to a design that is good enough. It's impossible to have a perfect design, right? So you have a design that is good enough, that create enough value to your customer, and that's the time when you start to sampling your new product, and you get many customers that are starting to test it. You get a lot of feedback, some positive and also some less positive feedback, and you try to improve your product from that feedback. So that's what I really do. Me and my team do. We do a lot of the development, so a lot of the R&D and also engineering type of work. And there are other types of challenges. And I would say that when you want to license something, you need to be able to get to a point where your customer is comfortable enough to license it. And that's really tricky because sometimes they really want you to do everything. They want you to scale that up until, and then they license because it's lower risk. Obviously, that's always a fine line, and you need to be able to get it far enough so that, you really can demonstrate that it is scalable, but you don't want to go too far because that's where you start to really, you need to invest a lot of money into CapEx and things like that. And that's really not what we want to focus on.
Interesting. Hey, let's focus in on the EVs. I appreciate that Nanoramic does other things, but something you said back earlier in the discussion when you talked about high surface area and conductive materials that store 5 to 10 times more energy. I know I'm grabbing little bits of our conversation, but
sure.
Can you bring this to the EV industry? I mean, can we actually have battery packs in EVs that store 5 to 10 times as much energy? Is that pie in the sky or?
Yeah, no, this is my main focus today. So I'm really happy to talk about that. Yes, I think in the case of EVs, what we do as a company is we focus on lithium-ion batteries, and we have an electrode, a new type of electrode technology for lithium-ion batteries, and I'm talking about cathodes and anodes as well. And it is a platform, which means that we use conventional active materials like cathode active materials, anode active materials, but we have a process to make the electrodes work much better. In terms of energy density, for this specific new technology, we proved that we increase energy density. So basically the amount of energy that you can store in a given weight or a given volume of a battery cell or a battery pack, we increase that by about 35%. Yeah, so that's what we're talking about. So it's a 35% increase, which is a huge number actually for this industry, because that means you can extend, the range of all these vehicles by about that amount. And it's not just about the energy density. So we increase energy density by 35%. We also allow for fast charging. This is another key topic for electric vehicles. It is important to be able to fast charge those batteries, because really that's the bottleneck. You cannot you cannot charge today a car faster than maybe 30 minutes or something like that when the car is totally empty, right? So but there is more and more kind of demand for vehicles that can be charged in maybe 15 minutes. And so this is one of the things that we allow with our electrode technology. And there is a third component, which is the cost. Cost is obviously another main kind of challenge. And we lower costs by having this alternative process to manufacture electrodes. And this can be, this can apply with all kind of active materials. Yeah, we don't work on a specific new material, but rather it's a platform, and we can work with many types of materials and many types of chemistries.
So yes to lithium. You could use lithium chemistry with
Yes.
with these sort of better electrodes, putting it into sort of
Yes.
in English. Now, so does that mean that, like, I mean, I have a little electric vehicle parked right here next to my office. Could we actually swap out those batteries and put in batteries, lithium-ion batteries with better electrodes, or are we not quite ready to do that yet? Or
yeah, so in practice, yes, because basically the electrode is a drop-in replacement, which means that if you look at the battery today, if you open it up, you'll notice you have three main components. You have the anode and the cathode. Those are the two electrodes. And then you have a separator that basically separates these two electrodes. The electrodes that we make are exactly the same. They look exactly the same as the ones you have in a battery. Just they're very different from a scientific point of view, but really they behave the same way, which means that you can manufacture batteries exactly the same ways. You have these like huge kind of coils that you can produce via roll-to-roll process, and then they can be processed, they can be notched, slit, and all these type of processes that are used to make lithium-ion battery cells. Yeah. So yes, you can absolutely do that. You can swap the battery, as you said. The key kind of difference is what is inside the electrode. And if you want, I can go more in details and I can explain how this works and why we're different.
yeah, I'd like to hear it. I think are we talking about the composite electrode technology?
Yes, that is correct.
Instead of being a sole sort of piece of metal, to put it in most simply, or you have, is it various fins or something like that, or how does that work?
Yeah, I would say so. We call it a composite in that you have you're mixing different materials and you're trying to improve the overall performance of the coating. Yeah, so the electrodes are always made via coating process. Basically, you have all these kind of metallic foils that is made of aluminum or made of copper, and then there are coatings that go on top of those foils. What we apply is a coating that has two main features. One is that in the case of cathodes, for example, we are PVDF free. So PVDF is a polymer that everybody uses in cathodes. We eliminate that, and instead we have a 3D carbon mesh that is made with nanocarbon technology. And you can think of this carbon mesh as really like a web that hosts all the active material particles. It connects them together, and it has the dual function of being the electric scaffold for the coating. So it's very electrically conductive, which means that the battery is very efficient. You don't dissipate power into heat, but rather you put charge in your battery. And also this web, it has some it has some binding properties. So it really works as a binder, but instead of using a lot of those polymer materials, which are basically plastics and glues and actually don't add anything good to the battery, just they need to stick together all the active material. We have this carbon web that has the same, role, but with a very good electrical conductivity. And this really allows us to have lithium-ion batteries that charge in less than 15 minutes, and also increase energy density by having thicker coatings. Yeah, this is the other key aspect of our process.
Very encouraging. I mean, so potentially every EV battery, I don't know, in 5 years from now or whatever, 10 years from now would take advantage of this technology?
Yeah, I mean, this is of course what we hope. I don't think you're going to have every battery suppliers that will adopt this technology, to be realistic. But I think a good share, yes, because it's not just about the performance, as I mentioned, but also it has to do a lot with cost. And this comes from the fact that we have a process that, by basically getting rid of these like polymeric binders, we also, our coating process can use different types of solvents. So we eliminate, a solvent that is called NMP, which is it is very difficult to dry, and we can actually use other solvents like water, which is the most friendly solvent, or ethanol, which is very easy to dry. So you can coat cathodes at a speed that is almost 3 times faster, kind of the conventional coating process. So that means that in the factory your throughput is much higher, which means that the same factory can actually produce more energy in the same year. Or if you're building a new factory, you can have a factory that has a much smaller footprint to produce the same amount of gigawatt hour per year. So really this means cost savings. And so that's why it's very appealing to the auto OEMs, but also the tier 1 battery suppliers.
How far off are you from being in sort of standard car companies' batteries?
Yeah, I would say today we are working with several of those companies to qualify the process. So I think basically, to be realistic, it's something that we should be able to see in the next 2 to 3 years.
That's fantastic. And right now, the marginal cost is, I know you're saving in manufacturing capabilities, and you're saving by getting rid of some nasty solvents, but is the marginal cost, does this increase the battery cost right now by 10%, 50%? What do you think?
By as much as 27%. Yeah, so we've done a study and we've seen it in some batteries, we can decrease the cost by about 27%. It really comes from different things. It comes from the process itself. As I said, it's NMP free, so it doesn't have that solvent. So all the steps that are related to recovering that solvent, the drying step is it's a much faster step because we use other types of solvents. So some parts come from this aspect, but also the fact that we are able to coat thicker layers. So when you coat thicker layers, that means that in your battery, there are less passive components. There is less aluminum, there is less copper, less separator, which means that you are maximizing the amount of active material, which is what really stores the energy in your battery cell. So at a cell level, that also is huge because really you can lower the cost. And when you combine everything together, we are talking about 27% savings in some of those cells.
You're getting 33% more range and 27% savings as a negative net marginal cost. So that's fantastic. How exciting to be working on such a huge, I mean, you're seeing the EV adoption rate flying. The J curve is in full bloom right now. So how are you, how does a guy like you keep balance? You talked a little bit about skiing. Are you spending still an inordinate number of hours in the lab?
Yeah, I used to do that. Yes, I used to spend many hours in the lab, like sometimes even sleeping there. I actually found out that, with also, when you grow up a bit, like you find out that actually it is important to have that balance that you mentioned, right? Because you don't want to burn out or anything like that. So you actually want to spend the right amount of hours, but quality hours where you really are efficient, you're 100%. So I think the answer to that is discipline. I think discipline is the right answer, where if you're very busy and you have a lot of things going on, you have work, you have family, you have yourself. So I think it is very important to be disciplined, to organize your day very well, starting from early morning, to night, and make sure that you really have space for everything. I think this is so that's what I do, and I find that that you can be very efficient and you can get things done, throughout the day. So
Good stuff. Hey, listen, thank you so much for being on this show and educating me and educating our listeners. I salute your works. Carry on. Good stuff.
thanks. Yeah, thanks so much. Yeah.
All right. Take care. Goodbye.
All right. Thank you. Goodbye.
That's it. Thanks for listening to Flanigan's Ecologic. We'll see you next time.